Alkenes are unsaturated hydrocarbons having the general formula CnH2n. Let's see how we can form these alkenes using different methods. Let's start with the first alkene, that is ethene. The common name of ethene is ethylene. Let's look at the laboratory preparation of ethylene. In lab, we use this arrangement. The reagent used in this case is ethanol. We heat ethanol in the presence of concentrated sulfuric acid. So when we heat ethanol in the presence of concentrated sulfuric acid, a gas is released, as is seen through the bubbles. The gas is insoluble in water, so it is collected on the top. Let's look at the reaction that is taking place. So we have ethanol. Ethanol is heated in the presence of concentrated sulfuric acid. Now, concentrated sulfuric acid has a special property. It is used for dehydration. That is, it removes water from the substances. Now, in this case, concentrated sulfuric acid removes water from ethanol. That is, this H is removed and this OH is removed. As it removes this water molecule, we get CH. Now, since this water molecule is removed, each carbon has only 3 covalent bonds. So, in order to complete its tetravalency, it forms a double bond. As this H and OH is removed, it forms a double bond. So, now each carbon has 1, 2, 3, 4 covalent bonds. So, by using concentrated sulfuric acid, that is by the dehydration of ethanol, we get ethene. So, the reaction taking place here is, we have ethanol, that is C2H5OH. In the presence of concentrated sulfuric acid, it forms the gas, that is ethene, and water is released. So, by dehydration of ethanol, we get ethene. Let's look at another method. This method is known as dehydrohalogenation. Now, from dehydrohalogenation, we know it means the removal of hydrogen and the removal of halogen. So, we take a compound C2H5Cl and we use KOH. Now, this potassium hydroxide is taken in the hot and alcoholic form. This is a very special reagent in organic chemistry. So, when it is taken in the hot and alcoholic form, it is used for dehydrohalogenation. What it does is, it removes one chlorine atom and one hydrogen. Now, the chlorine goes with potassium to form KCl and the H goes with OH to form water. So, whenever it is possible for water to escape, it tries to escape. So, let's see how is this reaction taking place. So, we have C2H5Cl. It reacts with hot and alcoholic KOH. So, this H leaves and this chlorine leaves. Now, as this H and this chlorine atom leaves, each carbon now has 3 covalent bonds. So, in order to complete its tetravalency, it forms a double bond. So, by using hot and alcoholic KOH, we form ethene. And this is done by dehydrohalogenation. That is, by the removal of one hydrogen atom and by the removal of one chlorine atom, which is the halogen in this case. We can use another reagent as well. So, when we use C2H5Br and hot and alcoholic KOH, so since we are using the same process, that is dehydrohalogenation, Br, bromine halogen in this case, and one hydrogen atom, that is replaced. So, hydrogen goes and forms water, bromine goes and forms HBr, and we are left with C2H4. That is the gas released, which is ethene. So, by using dehydrohalogenation, that is by the removal of hydrogen and halogen, we can form an alkene. Let's look at a question here. We are given this reaction and we have to identify A. So, let's see what we are given. We are given C2H5I, that is iodoethane, and this is made to react with hot and alcoholic potassium hydroxide. So, whenever you see hot and alcoholic potassium hydroxide, we know the process taking place is Dehydrohalogenation. That means the removal of one hydrogen atom and the removal of one halogen atom. In this case, our halogen atom is iodine and one hydrogen atom is removed. So the iodine goes and forms Ki. The hydrogen atom goes with OH to form water and we are left with C2H4. So A in this case is C2H4, which is ethene. So in the presence of hot and alcoholic potassium hydroxide, the iodoethane undergoes a process known as dehydrohalogenation to form the gas which is ethene.